The first step in working with SQLite in Android is to define your database and table structure, and the best practice for this is to create a Java class that extends a class named SQLite OpenHelper. I'll describe how to do this in the project named Create Database. As with other previous projects, I have some sample data that I'll eventually import into the database, and a model class that hints at the structure for the database table. I'll start by creating a class for the database table, and I'm going to put this into a new package that I'll name Database. The name of the class will be Items Table. This class will include a number of constants, setting the name of the table, the names and types of its columns, and other critical information. This takes a bit of code, so I've created a gist that I can copy from. The short URL is git.io/vi uppercase Q lowercase us. I'll select all of this code and then copy and paste it over into my class. Now, the name of the table can be pretty much anything you want it to be, and the names of the columns can be whatever you want as well. You actually declare the structure of the table in the SQL create statement, which is a simple string constant. But it's important to match the data types of the columns to the types of your model fields. In my application, I've created a model class named DataItem, and it has fields named item ID, item name, and so on. It has 5 strings, an integer, and a double value. And in my SQL create statement, once again, I have 5 text fields, the first 4 and then the last one, 1 integer, and 1 real column. The real column matches the double type in Java. I also have a bit of code here to delete or drop the table from the database. I won't actually execute these lines of code here, though. The execution of these SQL statements will go into the OpenHelper class. And so now I'm ready to create that class. I'll name my class DBHelper, and I'll set its superclass as SQLite OpenHelper from the package android.database.sqlite. I'll click OK, and that creates the class, and I immediately see a warning. I'll click into that line of code and use an intention action and choose Implement Methods. There are 2 abstract methods that you must override, named onCreate and onUpgrade. I'll add those to my code, and I see that there's still an error indicator, so I'll follow that path again, and this time I'm being asked to create a constructor method. So I'll select that, and then I'll choose the first version of the constructor and click OK. And the error indicators go away, and I'm ready to start adding some custom code. I'll need 2 constants that represent the name of the database file and the current version of my database structure. I'll add those here. I'll start with PSF for public, static, and final, and I'll press Tab to complete that. Then I'll set the type as string, and I'll create a constant named dbFileName, and I'll set it as nadias.db. Now, as I mentioned previously, the .db extension is not required. It's a convenience, and it'll help you recognize the file easily if you go look for it on the file system of the device. I'll add another constant, and this will be an integer, and I'll set its name as db_version, and I'll set it to a value of 1. The database version is managed by the framework. It must be an integer. Your first database structure can be number 1, but if you need to change the database structure after you've released an application, each time you release a new version of the structure, you should increment this value by 1. So the next version is 2, the next is 3, and so on. Now let's go to that constructor method. I generated it with 4 arguments, but that's more than I need. My constructor will only be called by my code, so I can decide how to structure it, and I'd like to simplify it. I'm going to just remove the last 3 arguments. The only thing I'm going to save is the context. And then I'll replace the name and the version with my constants, dbFileName and dbVersion. I don't need a factory object, so I can pass in null for that. Next, I'll customize my onCreate method. The first time the app opens and you open the SQLite OpenHelper object, it'll call the onCreate method automatically and pass in a reference to the managed database file. It's up to you to actually execute the code to create the tables you need. And this is where that items table class becomes important. I already have a constant available named SQL create that has the required SQL statement. So to create that table, I'm just going to call db.execSQL, and I'll pass in itemstable.sql create. If my database is going to have more than one table, I'll call the create statements for each of the tables in turn. And that's all I need to do in the onCreate method. Now, the onUpgrade method is slightly more complex, and here's how it works. Let's say that you've released a version of the application and it has database version 1. Then you restructure your database, you make some changes, and you increment the DB version to 2. The first time the user opens the new version of the application, the onUpgrade method will be called. Once again, you'll get a DB reference, but this time you'll get the old version and the new version. It's up to you to write the custom code that's needed, say to add columns to a table. But if you just want to wipe out the database and start over again, you can do this. First, I'll call the executeSQL method again, and this time I'll pass in itemstable.sql delete. And that's the SQL statement that drops the table from the database. And then I'll call the onCreate method. If you want to maintain data that's already in the database, you could perhaps export the current data, say to a JSON file, then drop the database, recreate it, and then re-import the data, and have that all happen in a single method. But again, for our purposes, simply wiping out the database structure and creating it from scratch will be good enough. Now I'll add some code to my main activity to use this code that I've just created. In the main activity class, I'm going to create a reference to an SQLite database object, and I'll name it database. I won't initialize it here. Instead, I'll do it in the onCreate method, and I'll place it right here after the call to set content view. I'll create an instance of my OpenHelper object, and I'll cast it as its superclass, SQLite OpenHelper. This will allow me to call methods of the superclass easily. But when I instantiate the object, I'll use my class, dbHelper, and I'll pass in this as the context. Then to open the database, I'll call database equals, and then I'll call dbHelper.getWritableDatabase. When you call the getWritableDatabase method, that will automatically call that onCreate method if the database hasn't been created previously. That will result in executing the required SQL, and the database will have been created. I'll add a toast message so I can see that this happened successfully, and the message will just be database acquired. Now, I don't know if it's actually just been created, because in the main activity, all I'm saying is give me the database reference. All of the logic that decides whether to create the table or not is all a part of the helper class. And again, it's all managed by the framework. So now I'll run the application. I see the message database acquired, and that tells me that everything worked successfully. But to verify it, as I've done before, I'll go to the Android device monitor, and I'll look at my virtual device's file system. I'll go to the internal storage area under data/data. Then I'll scroll down to my application's ID, that's com.example.android.data, and I see a new databases directory has been created, and there are two files, nadias.db and nadias.db-journal. You don't need to worry too much about the journal, but if you want to examine the database, you can pull it from the storage and look at it on your hard disk, and I'll show you how to do that in a later video.